All right, guys, let's see. Why is this not much larger than it is? Let's see if I can make this a little bit bigger for you guys. All right, so we're trying something a little bit new here. We'll see if I can write like I need to on this thing. All right, so we're starting chapter 5. So we're dealing with our randomness and probability. So we're kind of moving into some actual calculations. This is our probability chapter. It's a little tough sometimes because it's conceptual, but not as conceptual as the last one. And we'll see how this new format works for you guys. So, what is the law of large numbers? The law of large numbers says, oops, didn't write up there. Let's try this again. The law of large numbers says, it says that um, it says if we observe, so if we observe more, oops, that's an M, more and more repetitions, we'll actually get, I'll abbreviate this, the proportion approaches its actual probability. Okay, so let me turn my phone off here, guys, because I don't want it to go off. Its actual probability. So really what we're talking about is this, guys. So let's just take, you guys know this one pretty well. Oops, come on. That's because I'm not working on that one. Why is it not working? Well, because it's brand new. There we go. Let's just work this one in yellow. So let's just assume we have a coin flip. So let's just talk about, a coin flip. So if we know a coin flip, we know that the chance of getting tails, let's say, is 1 out of 2. That's theoretical. So if I flip a coin right now and I flip it over, I may get tails the first time. I may get heads the second time. And then let's say I flip it again, I get heads again. And then I get tails. And then I get heads. And then I get heads again. And then I get heads again. So I go on this streak, let's say. So if we look at this, the probability of getting tails is going to be 1, 2. It's going to be 2 out of 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be the probability of 2 out of 8, which is 1/4, which is 25%. Okay, that does not match 1/2. It doesn't match 1/2. So what we're saying is that if I do this more and more and more and more, and I keep doing it over and over and over again, what's going to happen is the probability that was 25% is going to actually increase and start getting closer and closer to 1/2. So, but you got to observe a lot of them. So there's a graph in your book that kind of goes over the long run here, and this is 0% and this is 100%, and it starts with like it's 0% probability on the first flip, and then what happens is it goes all over the charts like this. But as you get farther and farther and farther out, this thing starts to smooth out, and it starts to smooth out to exactly 50%, which is what we would guess. But at the beginning, because we don't have enough data points, it's going to actually fluctuate way too much. Okay. So, how do you interpret probability? It is the expected. So, we're going to talk about expected over the predicted. That's it. Okay. Percent. That's our probability. So, well, and we're talking about successes, right? Of successes. And so we're talking about successes in a large number of trials. Okay. So, and it's always between 0 and 1. And this is impossible. And this is guaranteed. So we've got impossible and we've got guaranteed. Okay. So watch out. The other thing you guys got to watch out for is the idea behind this. Is when you do your calculator, the calculator may give you like 1.003, and then it has something like, it says e to the negative 04. That is not an error. That is telling you scientific notation. So you've got to move this decimal over 4 spots. So this is going to be 0.0001003. Watch out for that guy, because everybody thinks they got an error. That's not an error. That's scientific notation. So watch out in your, that's supposed to be notation. I'm getting used to this, guys. All right, so let's look at the probability of getting a sum of 7 with 2 dice. So we know this. We know that the dice has 1, 2, 3, 4, 5, 6 on it. We also know the other one has 1, 2, 3, 4, 5, 6. Okay. So when we look at this, when rolling, so the probability of getting a sum of 7 when rolling 2 dice is 1/6. And just kind of let's go over this. So you can get a 3 and a 4 on this one, and you can get a 4 and a 3 on this one. You can also get a 2 and a 5, and a 5 and a 2, so that's 4 chances. And you can get a 1 and a 6, or you can get a 6 and a 1. So that's 6 out of 36 different possibilities, because 6 times 6 is 36. So that gives us a 1/6 chance, right? So if we're looking at this, you take your percentage and you divide it out, and this is going to become, I believe, 0.1666% here. Yep, that's it. So 0.166, not percent. That should be percent. And that in turn is going to be, there is a 16.6% chance of rolling a 7 with 2 dice. There we go. Okay, so that's the idea behind interpreting the value in its basic idea. So the idea is this on this next one. I'm almost done, guys. So if you imagine you're flipping a coin, so if we take this and we're going to flip a coin, and like I started up here, I don't remember what I started with. We'll go tails, heads, 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 and then we get a tail, heads, tail, and then we get heads, heads, and then we just keep going like that. And if you actually did this, you would just write down the results of 50 imaginary ones. And so if you just did that, and the idea is is that if you do imaginary flips, you can do a number generator 1 or 2. The idea what's going to happen is what I want to draw your attention to is when you do these, you're going to get these long streaks here. And these long streaks are going to be hey, what's up, buddy? Let me finish up right here. I got like about 5 minutes, maybe at the most. You're going to get these long streaks of heads and tails. And so the idea behind that is you get long streaks that don't follow the actual percentage. So let's talk about a couple of myths about randomness. Mr. Lamb is in here, guys. That's who I said what's going on. Biggest mistake is applying law of large numbers. That is a horrible piece of writing that I did there. Law of large numbers to a small sample. And then the last one is assuming previous probability affects next outcome. All right, guys. I'll work on writing a little bit better here. Don't forget tonight, your homework is 28. Homework 28, page 293, 137, 9, 11. And you guys are done. Now, this is the hard part. I got to get out of this, and I got to